Hello and welcome to this project on bird species prediction. So in this project, we will create a convolutional neural network, that is a CNN, and it will be able to predict a species of a bird with the image that we supply to it. So what we'll do, we will use different layers and other hyperparameters for building, training and testing this multi-class classification model. And in this project, we will be using Keras. So the steps we need to make this CNN or to solve this problem are: firstly, I'll show you how you can mount your Google Drive on your with your Colab notebook. This is important because after this you don't need to download the data locally on your system. You can just uh, connect your drive to your Google Colab. We will visualize the images that we will be working on. After that, we will analyze the dimensions to verify if all the images have same dimensions or not. The next step would be converting these images into a NumPy array and we will normalize them. After that, we will check for class imbalance, if all the classes have same data or not, all the classes have same images or not, same number of images. After that, we will split the data and perform one-hot encoding on the target data. Next, we will create the model architecture. We'll compile the model and then we fit the model. After that, we'll plot the accuracy and the loss against each epoch. Then we will pre-process the test data and make predictions on it. And in the end, we will visualize the original and predicted label for one of the test image. So this project, it can be used for educational purposes because it will get you a better idea of how you can create a CNN. You can further hyperparameter tune the model we will create to reach a higher accuracy or to avoid overfitting. It can be used by bird sanctuaries to identify different types of birds also. So let's start this project in the Google Colab. For this project, we will be using Google Colab, as Google Colab provides high computational power and convolutional neural network or deep learning requires that. In this project, we will be creating a convolutional neural network which will be able to predict some species of the bird. We will create this network using different hyperparameters like activation functions, learning rate, batch size, epochs, and we will build, train and test this multi-class classification model. This project is based on Keras. We will be using Keras. So let's get started. So initially, first we will mount the Google Drive on our Colab notebook so that we can use the dataset directly from our drive. And for this, you first need to upload the data on your drive and then we will mount this. So by running this command from google.colab import drive and drive.mount, we are mounting our Google Drive to Google Colab. So let's run this cell. So here you will see that it will ask you an authorization code, and in order to generate this authorization code, you need to run this URL. So I'll go to my PyAnalytics account. You need to allow this and copy this verification code, authorization code. So here you will paste that code and press enter. It will show us that our drive is mounted. So here you can see that our drive is mounted at content/drive. So after mounting the drive, the next step will be to locate the folder where our data is stored on the Google Colab to Google Colab. So here you can see that we will run this command, that is ls content drive my drive. Let's run this. So here in my drive, I have stored it with the name of bird species dataset. So we will load that in the next step. So this is the most important step. Here we are importing some of the required libraries Here you can see that we are importing some very important libraries from very important functions for CNN. From keras.layers, we are importing the layers that we will be using, that is conf2d, max pooling 2d, activation, flatten, dropout, dense. We will split our data using sklearn.model selection, train test split. We will create a sequential model, so we need to import that using keras.models. The optimizer, we are going to use optimizer Atom, and similarly all other libraries for one-hot encoding, for OpenCV operations, for visualizing the images, matplotlib, CV2, numpys and pandas. So let's run the cell and import all the required libraries that we need. So you can see that all our libraries are imported. So in the next step, I'll show you how we can visualize some of the bird images that we will be working on. Also, we will observe the dimensions of these images. So here you can see that I have set the path. I'm using the my drive bird species dataset, and in that we are using a particular folder, that is American Goldfinch. And I have created a loop which will subplot my images, 4 images in a row, and we are taking images from American Goldfinch folder, and we will display around 17 images, 17 and 16 images. So let's visualize those images and see what type of images we will be working on and what are the dimensions of these images. So we should be sure that all the images have same dimensions in order to create a model. So here you can see, you can visualize that these are the images that we will be working on. And as you can see here, the dimensions of the images are same, 224 by 224 for all the images. So now let's move forward. Now we will set the root directory for the dataset we are using, and we are also storing the Flutters names of the dataset. We will also create 2 empty lists for images and labels. So let's run this. So after this, we are reading the images and we are converting it into an array. Similarly, we will also append the list created above with the image and its label. Here in this for loop, you can see that we are converting it into an array, and similarly, we are appending the list that we have created above and adding its label to it. So let's run this. It will take some time because there are around 1000 images, 1000 or 900 images. So it will take some time to read them, convert them into an array, and also append the list created with the image and its label. So it took me around 10 to 15 minutes for convert these array into a NumPy array. So now let's move forward. Now let us visualize the number of classes that we are using. So the number of classes that we are using and how much data they contain. So we are checking for the data imbalancing here. Here you can see that we are using around 1, 2, 3, 4, 5 and 6 classes with data around 140, 41 in each classes. So there is no data imbalance. Now let's move forward. We will find out the number of classes that we'll be working on and store it into a variable, as we will be using it later in the model architecture. So as I already told you, we are working on 6 classes, 6 species of birds. Next we will check the shape of image in a single image. So here you can see that we have already visualized that image above, and it was showing us 224 by 224, and as it is a colored image, so channel will be 3, that is the RGB. Now let us check the shape of the image labels, which will be equal to the number of images that we will be working on. So here we can see that there are 811 labels, so we will be working on 811, that is 811 unique images for different species. of birds. Now let us test train split our data using the sklearn. Here you can see that we are splitting our data into X train X test and Y train Y test using the train test split, and we are passing the image list and label list as the data to be splitted. We are setting the size as 0.2, so it will split into 80% for training and 20% for testing. Let's run this and split our data. So after this is one of the most important step. So here we are normalizing the images by dividing them with 255, and also we are reshaping the X train and X test. So let's run this and normalize our images and also reshape our images in the X train and X test. So after this, we will be label binarizing our data, that is one hot encoding our Y data. So one hot encoding is important because it will stop our data from getting prioritized, stop our classes from getting prioritized. We will also print the sequence of the classes. So let's run this cell. So here you can see that these are the classes that we will be working on. These are American goldfinch, barn owl, carmine bee-eater, downy woodpecker, emperor penguin, and flamingo. These are the 6 classes of the birds, 6 bird species that we will be working on. Now the next important step is to split the data, the training data, into validation data and training data. So we are splitting the X train XVal, Y train YVal using train test split, and we are passing the X train and Y train data here. Similarly, the test size is same, that is 80-20%. So this is the network architecture for our model. Here you can see that we have used different types of layer according to their features. Namely, you can see that initially we have called the model as sequential. So as we are creating the sequential model, after that we have called a conv2D layer with a filter size 8, with number of filters 8 and a filter size of 3x3. So a conv2D layer, it is used to create a convolutional kernel that is convolved with the input layer to produce the output tensor. Here you can see that we have put the padding as same, and input shape is the shape of the images. So here you can see the shape of the images 224 by 224 by 3. So after that we are using a max pooling layer. So it is a downsampling technique which takes out the maximum value over the window defined by pool size. So the pool size here we have defined is as 3x3. Similarly, we are repeating the conv2D max pooling for 2 more times. After that, you can see that we are adding a flatten layer. So a flatten layer, what it does, it flattens the input and creates a 1D output, which is required for the dense layer after that. So a dense layer, it produces the output as the dot product of the input and the kernel. Here you can see that we are using 32 neurons for the first dense layer, and after that we are creating the final layer. And in the last layer you can see that we are using softmax as the activation function because it is a multi-class classification problem. After that, in the end, we are printing out the summary of this model. So let's run this cell and find out the summary of our model that we have created. So here you can see it shows us that our model is sequential. It shows out the parameters that will be used, that will be trained. It shows us different layers that we have used, and in the end you can see that there are 338,038 total parameters that will be trained. So after that we will compile the model, and while compiling the model we need to set the type of the loss, which will be categorical cross entropy for this case. Along with that, we need to set the optimizer, which we are taking as Adam with a learning rate of 0.0005, and we are taking the metrics that we will measure, that we will visualize as accuracy. So let's run this cell and compile our model. So after the compilation, the main step is to fit the model. So fitting the model with the data and finding out the accuracy at each epoch, how our model is learning, we need to run this command. So now we are training our model on 50 epochs and a batch size of 128, as you can see here. You can try for more number of epochs to increase the accuracy, but here we can see that the model has already reached a very high accuracy, so we don't need to run it for more. During each epoch, we can see how the model is performed by viewing the training and validation accuracy. So let's run this fit command and see the accuracy. So while this is running, let me tell you about epochs and batch size. So if you increase the number of epochs, the accuracy increases, but overfitting also increases if you see that the accuracy of the training data and the validation accuracy have a very high difference. That is, accuracy of the training data is low and the validation accuracy is very high. It means that model is getting overfitted. And in order to remove overfitting from our model, we use regularization and dropouts. We add regularization and dropouts. So here you can see that we reached an accuracy of 98.85 and a validation accuracy of 0.9077. So you can remove the overfitting you see here using the dropouts or regularization. Let's move forward. So now we will save the model in the H5 format because we will be using it later for prediction. Let's run this and save our model. So model is saved in our drive as we have set the drive here. Next we will plot the training history. So the training history is, it contains the history of the model, the accuracy, validation accuracy, and all other things like loss and validation loss. So here you can see that we are plotting the accuracy and the validation accuracy around each epoch. So let's run this and visualize it. So this is the model accuracy. Here you can see the training accuracy in the red line and the validation accuracy as the blue line. This is good if you want to understand how training is done, how our model was learning. You can visualize that from here. So now we will see how we can plot the loss for the model for the training history. So here you can see that we are using history loss and history validation loss, and we will plot it against epochs. So let's run this cell and see the history of the losses. So here you can see this is the graph for the model loss. The red line shows the training loss and the blue line shows the validation loss. So next we will evaluate the model to know the accuracy of the model on the test data. So for that we will use model.evaluate and we will pass the x test and y test data, and after that we will print the accuracy. Let's run this cell and find out the accuracy on the. So here you can see that the accuracy is 87.11, and as I have already told you, you can hyper tune this model changing different hyperparameters and reach a higher accuracy. So next we will store the predictions of the test data in ypred. So we are passing all the test data, that is x test, in model.predict, and we are saving the predictions in ypred. Let's run this cell and save our predictions. So after saving our predictions, next thing is we will try to visualize one of the image which we will further use for prediction. So this is a random image taken from X test, that is 6th image, and we will try to visualize it. After that further we will use it for prediction. So here you can see this is the image that we are going to use that we are going to predict. So here what we are doing, we are creating a list of labels using the object of label binarizer we used above, and we will print that list. And finally, as you can see here, we have written two print commands in which one will print the original label and the other will print the predicted label using the argmax function. So let's run this cell and find out the predictions. So here you can see that these are the labels of different classes, and originally this image that we visualized above is an American goldfinch, and it is predicted as American goldfinch. So our model is working absolutely fine, absolutely correct. So with this we came to an end of this project. So we started with loading the dataset into Google Colab using Google Drive, and we visualized the images that we will be working on. Normalizing the data is an important step, irrelevant of whether we are working with any type of dataset. We have to do normalization. After that, we created a CNN model, which is further used for predicting the bird species using the image supplied to the model. So this project, it can be used for educational purposes and to get a better understanding of how to create a network architecture for a CNN model. You can further hyperparameter tune this model to reach a higher accuracy. One of the use of this model can be that it can be used by bird sanctuaries to identify different types of birds. Next, I will show you how you can create an application, a Flask application for this bird species prediction. So let's move forward. So now we will see how we can create a Flask app for our bird species classification model. So in this, you can see that I have created a folder named bird species classification, and I have added some files into it. So let me show you all these files one by one and what are their uses. So let's see the config.py file. This is the configuration file. In this, you can see that I have created a class named config and with an object. So here you can see that I have passed a secret key as PyAnalytics. You can use any different key. In this, you have to set session cookie secure equal to true and default theme as none. Similarly, we will also create one more class, that is the development config, and we will set the debug for true. The next file is app.py. So in the app.py, you can see that whenever the main function will be called, app will run. So this is the main file for this application. Other than that, we will go to the app folder. In this, we can see the init.py file. So this init.py file is the initializer. Here you can see that we are importing Flask from Flask, and then we are passing the name of the app using app equal to Flask name. And here we are calling the config.development config as we defined in the config.py file. After that, you can see that we are importing views from app. So let's see what is the views.py file. So views.py file is exactly same, the model that we have created. In this, we will import some of the required libraries. Here you can see that we have imported app from app. We have imported request, render template and URL from Flask. From TensorFlow.keras, we will import models because we need to load model here. Similarly, we will import NumPy for mathematical computation, PIL import image for loading the image, and string random and OS libraries also. So for any Flask app, we need to set the initial file upload path. So here we are using that app.config initial file upload and set the path as app in that static folder and in that uploads folder. After that, we are loading the model. So you need to download that model that we already created on your local machine and save it in the app static model. So you have to create a folder inside app folder, name as static, and in that a model folder, and then you have to store that model here, the per species.h5 model that we already downloaded from our Google Colab. So this is our trained model. So as any Flask app will run, here you can see that there are two methods for that, get and post. So get is the initial method. It will execute to get the index page. It will show you the index page. And on the index page, the home page, if you perform any operation, if you perform any request, it will pass the method to post. So here in the post, we can see that we are generating unique image names. We are using letters equal to string.sky lowercase. Similarly, we are joining the name and we are passing it to uploads folder, the name of the file. Next, what we are doing, we are reading images, resizing them and saving them and pre-processing them for prediction. So here you can see that we have taken an image using the image upload, and we are opening it, the image that we've taken from the image upload, resizing it, setting the path for it in the initial file uploads. Then we are converting it into a NumPy array and we are changing its shape into 4 dimension. After that, we are using model.predict to predict this shape, to predict this image, and save the result in result variable. And after that, we will use the ind variable and store the result using the np.argmax. And here you can see that I have passes the name of the classes which we are using in this project. So as I already told you, we are using 6 classes. So these are those 6 classes. So what it will return? It will return the file name extracted text. After that, in the end, you can see that we have created a main function. So this main function will call the app to run. So this is app.run debug equal to true. Now let me show you some other important files. So in the templates, we can see the index.html file. So this index.html file is very important as it will design our front end. And in order to understand this index.html file, you should have a basic understanding of HTML and CSS. In this, we are using materialize.css, and I have stored it in the static folder, all the things that we are using for the front end. So here you can see the static folder. It contains CSS, which is the materialize.css. As I told you, you can study the documentation for materialize.css on the internet. Similarly, there is an images folder which contains the background image for our app, the background on which our app will run, the white background. We are using JavaScript, so we have also included that here, the materialize.js. This model folder contains our model that we have already pre-trained, and the uploads will contain the files. We uploaded PNG or JPG files. Now let's get back to index.html file. So in this index.html file, you can see that we have created our first container as bird species prediction made by PyAnalytics. After that, we are asking the user to upload an image in the second section and given a browse button to browse the image and upload it. After that, we can see that we will use this image and we will submit using the submit button. And after we submit, it will show us the prediction. And in the end, you can see that these are the scripts which we are using here. So these scripts are connected to the user inputs. All the user inputs will be handled by scripts as we get here. After this, let me show you some other important files. Here you can see that this is the proc file. So proc file is generally used for deployment. it tells the deployment app that which type of file it is. So it is saying that it is a web app, and Gunicon will run app from app with a timeout of 60 seconds. This is the readme file. It contains all the information that I'm telling you. And after that, we'll see the requirements.txt file. So a requirements.txt file, it contains all the information, all the dependencies, the libraries which are used in this project. So we can create this requirements.txt file using the command prompt. So let me show you how you can do that. You just need to copy the path of this folder where this folder is stored and open the Anaconda command prompt. So in Anaconda command prompt, we first need to move to that folder where our project is stored. So I've copied the folder. I'm using cd, that is change directory, and I'm passing the URL for that particular folder. So here you can see that we are entered the bird species classification folder. In this, you need to run the command pip reqs. So in order to run this command, you should have pip reqs installed on your system, and if it is not installed, you can install it using pip install pip reqs. So this will install pip reqs on your system. As it is already installed on my system, so it is showing requirement already satisfied. Now we will create our requirements.txt file. So for that, we need to run the command pip reqs. So as soon as we run this command, it will render all the files that we have stored in this particular folder, and it will check the dependencies, what all libraries do we used and what are their versions, and create a file which contains those versions and the libraries. So here you can see that it is showing me a warning as I have already created it, but in your system it will not show a warning like this. Now let's install all these requirements. If you are not installed these requirements, these libraries on your system, the application won't work. So we can simply install these requirements using the pip install -r requirements.txt. So what this will does, it will install all the requirements. Oh, that's a typo. We can change that to install. And what it will does, it will install all the requirements that we mentioned in our requirements.txt file. So as I have already satisfied all the requirements here on my system, so it is not showing, it is not installed. Yeah, but it installed pillow. Now the next step and the final step is to run the application. Our application is with the name of app.py. So for running that, we need to run the command python app.py. Just make sure that you are in that folder where your application is stored, and you need to run that command in that folder only. So we'll run this. So here you can see that it is running on this URL. Let's copy this URL. Let's copy this URL and paste it in our browser to see if our app is running or not. So here you can see this is the front end of our app. I have copied that URL and pasted it here. So this is the bird species prediction app made by Pi Analytics, and now we will test this app. So we will browse an image. I have already stored some sample images in my system. So let's take those sample images and we'll predict it. Open this image and we'll click on predict. So here you can see that we have already seen this image in our Google Colab, and it was predicted as American goldfinch, and similarly here also it is predicted as American Goldfinch. So our app is working absolutely fine. You can design this front end on your own using different methods, using different CSS, and make it more visually appealing. So with this, we came to an end of this application. Thank you.